Hello everyone. Today we will be going over how to find the greatest common factor for both real numbers and polynomials. Okay, so first, I want to make sure you have an idea of what we mean by finding the greatest common factor. Okay, so let's say, for example, we know that 6 is equal to 2 times 3. Okay, so the fact that we can make 6 equal a product of 2 or more numbers, we can easily say that 2 and 3 are both factors of 6. Uh, 6. I'll write that underneath there. Okay, so what if we also say, let's say for example, we know that 12 is equal to 2 times 2 times 3, or 4 times 3. Okay, that means we can say that 2 and 3 are both factors of 12. Now, finding the greatest common factor would mean finding the number that goes into both of those evenly. Okay, so I'm going to show you the steps on how to do that. Okay, so before we start, we're just going to do a quick little couple of seconds review of the distributive property, because that will come in handy. Okay, distributive property states that if you have 3 real numbers, let's say A, B, and C, you can distribute them such that A times B plus A times C. So if you have A times 2 real numbers, whether known or unknown, you can just distribute that A to both terms. So for example, if you have 5 times X plus 2, we can go ahead and distribute that 5. So it'll be 5 times X, which is 5 times X plus 5 times 2, which gives you 5X plus 10. Okay, so that's just a quick review of the distributive property. So when it comes up later, hopefully you'll remember it. All right. Now looking at our next page, these are the steps for finding your greatest common factor. Okay, so step number 1, you're going to find the product of primes using what we call a factor tree. Okay, and if you don't remember what a factor tree looks like, after a few examples, hopefully it'll make sense. Okay, step number 2, you're going to identify the common factors. Okay, step number 3, you're going to multiply the factors together that you received from step 2. Okay, step number 4 is one of those what if steps. If there are no common factors from step 2, then the greatest common factor is equal to 1. Okay, so if you have to finish writing, by all means, feel free to press pause and continue writing. But if you're all done, we're going to go ahead to our first example. All right, so let's say, for example, we wanted to find the greatest common factor of, let's say, 28 and 40. Okay, so if you remember your first step, you want to factor to the product of primes. Okay, so we have our product of primes, so we have 28, which is, you can use 7 times 4, 14 times 2, we're just going to go with 7 times 4. Okay, so we've factored that down to 7 times 4. Okay, now 7, you can't factor that down anymore. You can only factor it to 7 times 1, which really isn't factoring any further. So we'll go ahead and circle that one. Now that 4, you can factor that down some more to 2 times 2. And neither one of those 2's can be factored anymore since they're prime numbers. Okay, so we're all done. Same thing with 40. We can do 8 times 5, 10 times 4, doesn't matter at all. Okay, so we're going to go ahead and do 10 times 4. Okay. Now the 10, you can factor that down to 5 times 2. Okay. Now neither the 5 or the 2 can be factored anymore, so we're going to go ahead and circle those. Okay. Now the 4, you can factor that down to 2 times 2. Neither one of those can be factored anymore, so we're going to go ahead and circle those 2's. Which brings us to our second step, which is our common factors. Okay, so we know that 28 is equal to 2 times 2 times 7. So we just write 2 times 2 times 7. And we know that 40 is equal to 2 times 2 times 2 times 5. Okay, now we look for the values that they have in common. Okay, they both have one of their 2's in common, so we go ahead and put a circle over those. And they have another set of 2's in common, so we go ahead and put a circle over those. Okay, which brings us to our third step, which means our greatest common factor. They have these 2's in common, so we only put the 2 once. They have these 2's in common, so we put that 2 once. Okay, you don't multiply all 4 of those 2's together. Just if they have a 2 in common, you multiply that 2. If they have another 2 in common, you multiply that 2. If they both had a 7 in common, you just put the 7 one time there. Okay, so your greatest common factor is actually equal to 4. Okay. All right, let's do another example. Let's say if you want to find the greatest common factor of 55 and 21. Okay, so just like before, your first step is going to be the product of primes. Okay, so 55, that's pretty straightforward. That's just 11 times 5. And neither one of those can be reduced anymore, so we go ahead and circle them. And 21, we can make that 3 times 7. And neither one of those can be reduced anymore, so we can go ahead and circle them. Okay, so that brings us to our second step. So we know that 55 is 5 times 11, and 21 is 3 times 7. Okay, so as you will notice, there are no common factors. Okay, if you look at this step, we were able to find a 2 that both of them had in common and another 2 they both have in common. This one, there is no value that they both have in common. The only way you could kind of give them a value that they would have in common is to multiply both of them by 1 and circle a 1, because the 1 won't change the value. That's why when there's no common factor, your greatest common factor is actually equal to 1. Because you can just multiply, make that times 1, and make that times 1, and circle that one, and they'd have that common factor. But you don't have to do that. Because if they don't have 1 there, you know your greatest common factor is only 1. Okay, so hopefully that makes sense. Alright, so let's go ahead to our next example. Okay, so what if we wanted to find the greatest common factor of 15, 18, and 66? Alright, so we do the exact same thing we did before, but we do it for 3 terms. Okay, so remember your first step, which is product of primes. Okay, so we have 15, we have 18, and we have 66. Okay, so 15, we can factor that to 3 times 5. And neither one of those can be factored anymore, so we can go ahead and feel comfortable circling those. 18, you can factor that to 6 times 3, 9 times 2, doesn't matter at all. So let's go with 9 times 2. Okay, and the 2 can't be factored anymore, so we went ahead and circled that one. This 9, you can factor that to 3 times 3. Okay, so 66, you can do 11 times 6, you can do 22 times 3, doesn't matter at all. So we'll do 22 times 3, and if you do 11 times 6, you'll notice that you'll end up with the same final product of primes. So 22 is 11 times 2. And we can go ahead and circle those, which brings us to our second step, which are common factors. So 15, which is 3 times 5. Let's straighten up that 1 a little bit more. There we go. 18, which is 2 times 3 times 3. And 66, which is 2 times 3 times 11. Okay. So if you look at all 3 of them, the only value that they have in common is 3. So your greatest common factor is equal to just 3. Remember, you don't multiply those together. We're just looking for the value that they have in common. Okay, so our greatest common factor is just 3. Alright, so let's do another example. Well, if we want to find the greatest common factor of 8, 20, and 28. Alright, so I want you to press pause and give this one a try for yourself. Alright, so assuming you've pressed pause and you've worked this one out and you're all done, we're going to find the answer. Okay, so your first step, just like up here, find the product of primes. Okay, so we have 8, we have 20, and we have 28. So the 8, you can make that 4 4 times 2, where we know that 2 can't be reduced anymore, so we can go ahead and circle it. We'll bring that up some. There we go. And the 4, you can make that 2 times 2, where neither one of those can be reduced anymore, so we go ahead and circle those. Okay, 20, we make that 5 and 4, 10 and 2, does not matter. So we'll make that 5 times 4. Okay, so the 5, can't reduce that anymore, so we go ahead and circle it. The 4, you can make that 2 times 2, and neither one of those 2's can be factored any lower, so we can go ahead and circle those. Okay, and 28, you can make that 14 and 2, 7 times 4, doesn't matter. So we can go ahead and make that 7 times 4, where we know the 7 can't be reduced anymore, so we go ahead and circle it. That 4, you can factor that to 2 times 2, and neither one of those 2's can be factored anymore, so we can circle those also. Which brings us to our second step, which we find the common factors. So we know that 8 is 2 times 2 times 2. We know 20 is 2 times 2 times 5. And 28 is 2 times 2 times 7. Okay, so if we look, they have a 2 in common. We'll bring that up a little bit. And they have another 2 in common. So our greatest common factor is equal to 2 times 2, which is 4. Alright, so hopefully the steps are starting to make some sense. Now we're going to look at the greatest common factor if all of your terms were just variables. Okay, so let's say, for example, you wanted to find the greatest common factor of x squared, x to the third, and x to the fifth power. Alright, now we're going to go with our first step. And we know that our first step is product of primes. Alright, so the product of primes with just variables is not that difficult. We don't need a factor tree. X squared is x times x. X to the third is x times x times x. And x to the fifth power is x times x times x times x times x. Okay. Now, just like before, our second step, we look for our common factors. Okay, so all three have this x in common. And they also have this x in common. Okay, we know that our greatest common factor, look at this, x times, with that one in common, x, which is x squared. Okay. Now the key thing about having just the variables is that you honestly do not have to go through all these steps. So straighten up that up a little bit. Okay. There's a shortcut method to where you could find the greatest common factor of just the variables in literally about 2 seconds. Okay. So what if you wanted to find the greatest common factor of x to the 15th power, x to the 38th power, and x to the 12th power? Okay? Now, if you look up here, if you notice, after x squared, they will no longer have anything in common. Okay? Because that's the smallest exponent. If you had to write out x times x times x 15 times, and then do it again 38 times, and then do it again 12 times, they will stop running out of x values in common as soon as you hit 12, because that's the smallest exponent. Okay, so the reason I said you could solve this in 2 seconds, which really was not an exaggeration, greatest common factor of x to the 15th, x to the 38th, and x to the 12th is literally just x to the 12th because it had the smallest exponent. And you're done. So that's the easy part. When they're just variables and they're the same variable, you just look at the exponent. Okay, so let me make a quick note. The greatest common factor of 3 terms with the same variable, well, let's say really 2 or more terms. It doesn't have to be 3. Let's say 2 or more. That's a little more precise. Of 2 or more terms with the same variable. Is just the variable with the smallest exponent. Alright, so let's say, for example, we do another quick example. Find the greatest common factor of y to the 48th power, y to the 26th, and y, I actually forgot my and y to the 30th power. So honestly, you should know the answer already, because you're just going to look at the smallest exponent, which is y to the 36th. I mean 26, sorry for that. Okay, that's the smallest exponent, y to the 26th power. Because if you multiply them all together and started circling common factors, you'd stop at 26. Alright. Now what if we have a mixture of variables and numbers? So what if we wanted to find the greatest common factor of 20x squared, y squared, and 6x, y to the third? Okay. So when you have more than one variable and you have numbers thrown in there, it's really the exact same thing. You just want to have a process. Okay. Okay, so the process you're going to follow, or if you have one of your own that works, you're more than welcome to use that one. Find the greatest common factor of the, remember you have the numerical coefficient, which is just a fancy way to say the number part of the term. Don't really need that comma. So numerical coefficient and each individual variable. Okay, so that means you're going to find the greatest common factor of 20 and 6. You're going to find the greatest common factor of x squared and x. And then you're going to find the greatest common factor of y squared and y to the cube, y to the third power, or y cubed. Okay. Then multiply them. Okay, so once you find each individual greatest common factor, you're going to multiply all three of those to find the overall greatest common factor. Okay, so let's say we go ahead and solve that. I'm just going to separate this a little bit. There we go. Okay, so remember your first step. You're going to find the greatest common factor of 20 and 6. Then you're going to find the greatest common factor of x squared and x. And really, you can do that without even writing this down. And the greatest common factor of y squared and y to the third. Now these two, we can do that in our heads. Greatest common factor of x squared and x is just x. So we're good there. Greatest common factor of y squared and y to the third, smallest exponent is 2, so that's y squared. We're good there. Those two already done. Now the greatest common factor of 20 and 6. Okay, we know that 6 is 2 times 3. And 20 is 4 times 5, where the 5 doesn't get reduced anymore. And you have 4 is 2 times 2. So we know that 6 is 2 times 3. And we know that 20 is 2 times 2 times 5. So the greatest common factor of just the 6 and the 20 is 2. Okay? So once you have the greatest common factor of 26, so the numbers, the x, and the y's, just multiply all those together. So your greatest common factor of 20x squared y squared and 6x y to the third is 2 times x times y squared. 2x y squared. And again, most of the time you won't even have to write these two down once you really get comfortable with it. You can just look at the x squared and x and know that the x is the greatest common factor for that variable. Okay, so hopefully that made sense, but we're going to go ahead and do a few more examples. So let's say, for example, if we wanted to find the greatest common factor of negative 18 y squared, negative 63 y to the third, and 27 y to the fourth. Alright, so we're going to go ahead and get the easy part of that out the way, because we know that the greatest common factor of y squared, y to the third, and y to the fourth is y squared, smallest exponent. So that part is out the way. Okay, now we have to find the greatest common factor of the numerical parts. Okay, so to find the greatest common factor of negative 18, negative 63, and 27, we have to follow our steps. So first, you have product of primes. Okay, so we know negative 18, if you do the factor tree, that's going to be negative 1 times 2 times 3 times 3, where you have 9 times 2 times negative 1. Same thing with negative 63. If you do the factor tree, would be -1 times 3 times 3 times 7, or 9 times 7 is 63 times -1. And 27 would be 3 times 3 times 3, or 9 times 3 is 27, and just factor from there. Okay, which brings us to our second step, which is the common factor. Okay, so we see all three of them have a 3 in common. And actually, all three of them have another 3 in common. Okay, so we know that the greatest common factor of just the numbers, -18, -63, and 27, is 3 times 3, which is 9. Okay, now remember, this is just the greatest common factor of the numbers. To find the greatest common factor of all three of these terms, you just multiply these two together. So that means the greatest common factor of -18y squared, -63y to the third, and 27y to the fourth is equal to 9y squared. Okay, so that's actually your answer. Alright, so hopefully that made sense. Alright, so we're going to do another example. Find the greatest common factor of 28d to the third power, 32d to the third power, and 20d to the fourth power. Alright. So once again, we're going to go ahead and do the variable part first. Knock that out really quick, because the greatest common factor of d to the third, d to the third, and d to the fourth is, of course, d to the third, because it's the smallest exponent. Okay, so that part's done. Now we have to find the greatest common factor of 28, 32, and 20. Okay, so you have your first step, which is the product of primes. Okay, so if you did your factor tree, you will see that 28 is equal to 2 times 2 times 7, or 4 times 7, and the 4 is factored down. 32 is equal to 2 times 2 times 2 times 2 times 2. And we know that 20 is equal to 2 times 2 times 5. Okay, so your second step, we have to find the common factors. Okay, so 2 times 2 times 2, not 2 times 2, but 2 is your common factor. And if you see here again, 2 is a common factor. That means your greatest common factor, which is your third step, is 2 times 2, which is 4. So, and actually, let me clear that up, because once again, that's just the greatest common value of the numbers. I don't want there to be any confusion. So the greatest common factor of 28, 32, and 20 is 2 times 2, which is 4. Okay, don't want any mistakes there. So that just means that since you have the greatest common value of the numbers and the greatest common value of the variables, your overall greatest common factor of 28d to the third, 32d to the third, and 20d to the fourth is 4d to the third. All right, so hopefully that made sense. All right, so we're going to go to one more example. And there we're going to look at factoring polynomials, or the greatest common factor of polynomials. Okay, so let's say, for example, I want to find the greatest common factor of a to the third b squared, a to the fifth b, and a to the sixth b squared. All right. Now this one, I want you to press pause and try this one on your own. All right, so I'm assuming you've pressed pause and you've worked this one out. Okay. So if you notice, there's no numerical coefficient. There's no number there. We just have A's and B's. That's it. So the greatest common factor of a to the third, a to the fifth, and a to the sixth power is, of course, the smallest exponent, which is a to the third power. Now, the greatest common factor of b squared, b, and b squared is b, the smallest exponent, since b is just the same as b to the first power. Now, since we don't have to find the numerical greatest common factor, we just multiply these two together. So your greatest common factor of a to the third b squared, a to the fifth b, and a to the sixth b squared is just a to the third times b. Okay, so that would be your answer. All right, so now we're going to find the greatest common factor in a set of polynomials, or polynomial terms. Okay, so let's say, for example, find the greatest common factor of the polynomial 5ab plus 10a. Okay. So really that's just asking you what's the greatest common factor of each individual term. And really it's the exact same thing we just finished doing. They just put a plus sign in between them instead of commas. Okay, so we find the greatest common factor of each term. So find the greatest common factor of each term. All right, so the greatest common factor of both 5ab and 10a. That's what we're looking for. Okay. So remember what we did before. we have the greatest common factor of just the numbers. Okay. Then we have the greatest common factor of the a variable, a and a. Now the thing you want to make sure you're looking at, you have the greatest common factor, you have a b here, but you don't have a b variable there. So the only way you can have a greatest common factor is if you have a b variable in both terms. So there is no greatest common factor of the b variable. Okay, so really all we have to find is the greatest common factor of 5 and 10, and the greatest common factor of a and a, which we can do that in 2 seconds because that's just a. Okay, so now the greatest common factor of 5 and 10, 5 is just 5 times 1, or 1 times 5, or just 5. And 10 is 2 times 5. So the only number they have in common is 5. So the greatest common factor of both of those terms, once we multiply these two together, I'll say greatest common factor of 5ab plus 10a is equal to 5a. Alright, so now what we're going to do, we're going to take this same polynomial, and since we found the greatest common factor, we're now going to factor the polynomial. Okay, with 2 completely different steps. Okay, so what if we wanted to factor the polynomial 5ab plus 10a? Okay, so if you're going to factor it, which is completely different from finding the greatest common factor. Okay, so if you're going to factor it, you're going to move the greatest common factor to the front of your parentheses. Okay, the lead one below. Okay, so that means your greatest common factor, so we have 5ab plus 10a is going to equal 5a. And what you want to do is, and this is just a little bit of a hint, right underneath it, write your original. So you have 5ab plus 10a. And you have your 5a up front. So now what you want to do is you want to look at 5a and go 5a times what will give me 5ab. Okay, so 5 times 5 is 1, so we can just leave that 1 there. A times a, okay. The only thing missing is a b. So we put our b up there, because if we distribute this, 5a times b will give us our 5ab. So we're good there. That's why we went over the distributive property earlier. Okay, so now 5 times what will give us 10? 5 times 2. Okay, a times what will give us a? 1, so you can leave that blank. So if we distribute this, we'll have 5a times b is 5ab, and 5a times 2 is 10a. So the factor is actually 5a times b plus 2. Okay, remember, the 5a is just the greatest common factor from those terms. That's why you moved it to the front. But the factor itself is 5a times b plus 2. Okay, and again, we're going to go over factoring again in later videos, so don't worry about it. You'll get plenty of practice. Okay, so let's go to our next example. Okay, so what if we wanted to find the greatest common factor of negative 9a to the 5th power plus 18a squared minus 3a. Now remember, finding the greatest common factor and factoring the polynomial, two different things. We're just finding the greatest common factor for now. Okay, so we're going to factor each term. We'll find the greatest common factor for each term. Okay, here we have a to the 5th, a squared, and a. So starting off, we can knock that out really quick. The greatest common factor of a to the 5th, a squared, and a is, of course, just a, since that has the smallest exponent. Now we find the greatest common factor of our numbers. So we find the greatest common factor of negative 9, 18, and negative 3. It's a negative 3 there. Okay. So just working that out on the side, we know that negative 9 is equal to negative 1 times 3 times 3. We know that 18 is 9 times 2, which is just 2 times 3 times 3. And we know negative 3 is equal to negative 1 times 3. Okay, so the only value that all three of these have in common is a 3. So the greatest common factor of negative 9, 18, and negative 3 is 3. Okay, so they don't have a negative 1 in common, so it wouldn't be negative 3. Okay, so the greatest common factor of all three terms is equal to 3a. Okay, that's your answer there. Now, if we want to find the factor, that's a different step. Okay, so if we wanted to factor the polynomial, negative 9a to the 5th plus 18a squared minus 3a. Again, we just move our greatest common factor to the front of our blank parentheses. Move your greatest common factor to the front of your parentheses. Alright, so we have our greatest common factor where we put 3a right there. And again, just a little hint. Put your original polynomial right up underneath it. So you have negative 9a to the 5th power plus 18a squared minus 3a. Okay, so 3 times what will give you negative 9? Negative 3. 3 times negative 3 is 9. Okay, and a times what will give you a to the 5th power? Okay, so just a little side note there. A is the same as a to the 1st power. So a to the 1st power times a to the 4th power is a to the 1 plus 4 power, which is a to the 5th. So a to the fourth power gives you that. So a to the first times a to the fourth power is a to the fifth power. So if we distribute, we'll get negative 9a to the fifth power. Okay, so plus 3 times what will give you 18? 3 times 6 is 18. So we put a 6 there. A times what will give you a to the second power? You know, a times a is a squared. So we put an a there. Okay, 3a, or 3 times what will give you negative 3? That's negative 1. So basically 3a times negative 1 will give you negative 3a. So if we distribute these, you can always double check by using distribution, you should end up with your original equation. This is just the factored version of that. Okay? So the factor of negative 9a to the fifth power plus 18a squared minus 3a is equal to 3a times negative 3a to the fourth plus 6a minus 1. Oops, sorry for trying to squeeze everything. I don't know why it started way over here. Okay, so that's your factor. Okay, and again, we're going to be going over factoring again, so don't worry if you're not 100% comfortable with it. Okay. Alright, so sometimes the greatest common factor of a polynomial is another polynomial. So sometimes the greatest common factor of a polynomial is another polynomial. And usually when you have a polynomial inside of a polynomial, finding the greatest common polynomial is a lot easier. Okay, so I'll show you what I mean by that. So let's say, for example, you want to find the greatest common factor of the polynomial 5 times x plus 3 plus y times x plus 3. Okay, so I'm going to show you the step-by-step way to find it, and then I'm going to show you the shortcut, which is really, 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 really quick. Alright, so first, remember our first step. You have to find the product of primes, or in this case, you just have to factor it. So 5x plus 3, 5 times x plus 3, really that's just 5 times x plus 3. Nothing really fancy about that. Same with y times x plus 3. Y times x plus 3 is just y times x plus 3. Alright, so remember the second step. You have to look for the common factor. The only one they both have in common is the x plus 3. So that means your greatest common factor is just the x plus 3. Okay, and that's your answer. Okay, now if you wanted to factor it, there's a very quick way to factor. And I'll show you that one. So, example, you want to factor 5 times x plus 3 plus y times x plus 3. It's a really easy way to do it. Okay, so I'm just going to rewrite it. 5 times x plus 3 plus y times x plus 3. If you look at these two, the x plus 3, they both have in common. It's already factored for you. They have the x plus 3 in common. So remember, when you're factoring, you get your common factor and move it to the front. So you have x plus 3. And since you've already factored those out, you just move those out to the front of your blank parentheses. And whatever is left goes inside the second parentheses. So here you have a 5 left, and you have plus y left. And that's your factor. So if you did the FOIL method, and then distribute and all the other stuff, you'd end up, but really if you just distribute this to both of those terms, you'd end up with the same answer. Okay, so that one's pretty straightforward. Alright, so let's do another example. Oh, there we go. So let's say, for example, we wanted to find the greatest common factor of 7 times x plus 4 plus x times x plus 4. Okay, and you press pause, and I want you to try this one. It should only take you a couple of seconds to use the shortcut method. Okay, so assuming you've already pressed pause and you have worked this one out. So if you have 7 times x plus 4 plus x times x plus 4, you already have your common factor. So you just move that out to the front. So you have x plus 4, and you go ahead and cross that out. So whatever's left goes into the other parentheses. So you have 7 plus x. Okay, so your greatest common factor is x plus 4. But your factor is this. And I probably should have put and factor. Okay, so let's say we do another example. Let's say if we just wanted to factor. Don't find the greatest common factor, just factor. So factor x times y plus 8 minus 2 times y plus 8. Okay. Okay, so again, press pause, and I want you to try this one. Don't worry about the greatest common factor, just factor. Alright, so assuming you've already paused it and done the work, we see our greatest common factor there. Okay, so we move our greatest common factor to the front. And those two, we can go ahead and cross those out. And whatever's left goes into the second set. So you have x minus 2. Okay, and that's our factor. Okay, now we know our greatest common factor was y plus 8. Okay, so that's just a little side note there. But our actual factor is y plus 8 times x minus 2. Alright, so hopefully this made sense, and I'll see you on the next video.